Coming to the arrangement of bus bars, and third one is a double bus bar system. The name indicates that the double bus bar system is nothing but it contains two bus bars. One is called as main bus, and other one is called as spare bus or duplicate bus. Both are said spare bus or duplicate bus. So generally, the double bus bar contains two bus bars. Both are connected by a bus coupler so that any fault occurs in one bus, then the remaining bus will continuously operate not to interrupt the power supply. That is the main advantage of double bus bar system. So in single bus bar, if a fault occurs, it will interrupt. In single bus bar system, any fault occurs in one section, then it will interrupt. But whereas in double bus bar system, if any fault occurs in one bus, then the remaining bus will operate continuously for not to interrupt the supply. So it consists of two bus bars. One is called as main bus bar, and another one is called as spare or transfer or duplicate bus bar. Each bus bar is designed to carry the full substation load. Means when a fault occurs in one bus, then the remaining bus will carry the full load. That is the designation of bus bar. So it mainly contains main bus bar, spare bus bar, and we have the bus coupler, which consists of circuit breakers and isolators. So under normal conditions, all incoming and outgoing feeders are connected to the main bus bar. During fault or maintenance of main bus bar, load is transferred to the spare bus bar, so continuous of supply is maintained. So under normal conditions, all the incoming and outgoing feeders are connected to the same main bus bar only. So when a fault occurs in main bus bar, then whatever the load that is connected to the main bus bar is shifted or transferred to the spare bus bar through bus coupler so that the spare bus bar will act as a main bus bar and it will continuously supply the power. The advantage of double bus bar system, it is having high reliability, no shutdown during the bus bar faults. Means any fault occurs in main bus bar, then the spare bus bar will operate. So continuous supply of power takes place. So there is no need of shutdown during any fault occurs in any bus bar. It allows easy maintenance without interrupting supply. Suitable for important substations. So this is advantage of double bus bar system. Coming to the disadvantages. So it is having the higher initial cost. It requires more space and more complex operation compared to single bus bar. So it is having the high initial cost because we require the another bus bar. All bus bar, main bus bar and spare bus bar both are connected to the bus coupler so that we require the additional equipments like isolators and circuit breakers and just require the parallel operation of bus bars. So it requires more space and as compared to the single bus bar, it is just quite complex. So frequently used for voltages above 33 kV and these are mainly used for major outdoor substations and transmission and primary distribution networks. This is about the double bus bar system. Coming to the next substation, that is gas insulated switchgear. So gas insulated switchgear or gas insulated substation is used to mean a type of electrical switchgear in which the majority of components are enclosed in gas-filled chambers. Means the name indicates that here we are insulating the insulating media is gas. The main gas that is used in gas insulated substitution is sulfur hexafluoride. So we have the type of circuit breaker that we have is SF6, and the same gas insulated substation here the main gas used is sulfur hexafluoride. So why we are using the sulfur hexafluoride? So what are the properties and why we are preferring the sulfur hexafluoride as compared to the remaining gases? So the gas offers superior electrical insulation as well as arc quenching properties when compared to air. So as compared to the air substation or air insulator substation, the SF6 gas offers very superior electrical insulation as well as arc quenching properties. So as a result, switchgear size is greatly reduced when using gas insulation. Weight 2, this makes JS switchgear suitable for confined indoor spaces where high voltages are to be carried out. So gas insulator substation is generally preferred for having the superior electrical properties and having the arc quenching properties. So why how we are designing the gas insulator substation or gas insulator switchgear? So the design of gas insulated switchgear includes a dielectric gas, typically sulfur hexafluoride, to insulate the various switchgear components in grounded metal enclosures. So the gas is usually at the moderate pressure of 400 to 600 kilopascals. So it is having the pressure of nearly 400 to 600 kilopascals. So because of this moderate pressure, it allows to prevent the leakaging or condensing in low temperatures. So why we are going for this moderate pressure is to prevent the leakage or condensing in low temperatures. So coming to the property of the SF6, SF6 is a colorless inert gas that's roughly having almost 5 times the density of air, and it is nearly offering 2 to 3 times as much as insulation. So why we are going for SF6 gas is because of this having the high density. It is nearly almost 5 times the density of air, and it is having the capability of 2 to 3 times much more insulation as compared to the air. So when it comes to handling arc flashes, the gas is also much superior and around 100 times better than air. So SF6 is a colorless gas which is having very much density, and also it is having the high insulation property, and it is also operate very fastly during arc flashes or arc quenching, which is very better as compared to the air. That's why gas featured substation we are going for SF6 gas. That is a property of SF6 gas.